Good afternoon, everyone. This afternoon, we have the pleasure to welcome Mr. Anders Philipsen, who is the Managing Director of Environment Solutions, the company behind the technology of NoFloods that provides very successful solutions for the prevention of different type of flooding at international level. With the presentation of Mr. Philipsen, the course enters into the emergency solution to prevent flooding damages and facilitating proactive means to the flooding respondents instead of the reacting activity that usually take place. As mentioned before, this presentation will be recorded and will be available later on YouTube to get a wider audience. Let's welcome Mr. Anders Philipsen. Anders, the screen is yours.
Thank you so much. Thank you so much. It's a pleasure to make this presentation for you. I'll make this presentation and it will be a combination of a lot of cases, a lot of pictures, and I'll be happy to answer all the questions you may have. So what we do, we basically enable rapid flood protection and land reclamation using deployable barriers. And this is basically how it looks when we have a storm surge and we've deployed our barriers. This is a storm surge actually last year, but it happens all the time. I was supposed to present to you last week, and actually I had to help a client who had this building basically being flooded as the presentation was going on. So we had to deploy the barrier in water and then surround the building. And you can see to the left how the water was actually already approaching. Another deployment we did the day after, it was actually at this point of time, the storm already hit Denmark. So we had wind up to 25 meters per second. And we had to dam up an area with a barrier. And what you see here in the middle, or actually also on here, it was how it looked when we came to the location. We already had a lot of flooding. It was already flooded with 40 centimeters of water. And to the right, it's basically how it looked after finishing. This is like the procedures, you know, so we are deploying in water, pulling the barrier out, filling it up with water. Quite challenging since you can have wind from one direction and water from the other. But basically, we managed. Just a quick question. Do you see when I'm changing the slides?
Yes.
Excellent. So why should you care about flooding and flood protection? I mean, per category, it's the world's biggest natural disaster. About 2.3 billion people affected in the period from 95 to 15, and more than 157,000 killed. And looking ahead, you're facing $1 trillion in cost annually when we reach 2050. So the numbers are absolutely significant. One thing is the economic cost. The other thing is actually all the immaterial costs. And you have the psychological consequences. I mean, people suffer from stress, sleep problems, you know, when they have their house in risk of being flooded. And this was a statistics made after one of the flood events where we deployed our barriers. Well, this was 1 year before when they were affected, and then we deployed that location after. So this is also, besides the economic cost benefit, where we usually look into like a ratio of 1 to 100 for the investment to the amount we save, then we have this on top. Brief about our company. We basically established back in '99. We have experiences from a lot of countries in the world. We have cases from more than 20 countries. We have partners in about 30 countries. And we have 3 product lines and 2 patents. And what we do is basically, we fight water with water. And the idea originated back in time, how do you stop a forest fire? And you can do that with a controlled fire. And then these engineers thought, okay, what can we do about flooding? If you can fight a fire with fire, yeah, can you fight water with water? And this way they started to work with these inflatable barriers where you're filling water into the tubes. And when I personally entered this company, which we bought the company a long time ago, we said, is it really true that it's, you know, you only use 0.5% of the resources you would use fighting with sandbags? And then we simply had to make the test because we didn't believe how many resources you would use fighting floods with the sandbags. So we actually tested, and in basically in 4 hours we were able to build a barrier 2.3 meters of protection. So yeah, we tried it ourselves. We know what it takes to do a sandbag barrier, and it's absolutely a no-go. It's very theoretical approach instead of, well, if you have a doorstep, that's fine. But if you're talking about large-scale flood protection, then it's absolutely a no-go. Good. As a company, I mean, sustainability is in focus, and it's basically a part of our DNA. Same with the Sustainable Development Goals. Our focus is good health and well-being, responsible consumption and production, and climate action. Since we fight water with water and use the water as a resource, we are able to fight floods by the use of 0.5% of the resources you would normally use. And in regards to the climate impact, we basically save 99% of the CO2 emissions you will have with alternative methods. On top of this, if you reuse the material, that number would be even better. And at the end of time where we are unable to use the barrier, we can take it back and recycle it and reuse about 97% of the materials in new plastic products. We have 3 products. We have the inflatable barriers, we have aluminum barriers, and we have this self-rising barrier. And it means we have different solutions to fight floods, whether it's in 1 meter sections or whether it's up to 200 meter sections, which you could prolong with another 200 meter sections. So we have different options to adapt and offer the clients, you know, a solution depending on the need they may have. This is the inflatable barriers I started to show you in the beginning. And at this location, we have we deployed about 3 kilometers of barriers holding back the flood water. And as you can see, you can navigate easily in the terrain, make different curves, and basically we say you can deploy the barrier where you would normally be able to drive with a vehicle. The case here, we had barriers deployed for 3 to 5 days with water pressure on the barrier. The flex wall is the self-rising barrier. Great alternative, easy to redirect water, basically packed in a bag. So the weight of a 10-meter section is the same like 1.5 sandbag. And here we have a 10-meter section, basically replacing, I would say, about 50 sandbags per meter. So about 500 sandbags are replaced in less than a few minutes. So here we show how we easily redirect water. The aloe barrier is also a strong and durable solution. We often recommend this solution if you do not have access to water. Then you can rise up, in front of gates or buildings that's in a far distance from the water source. Everything, all solutions are packed in boxes like this. And I can really emphasize being prepared, having clear action cards, having the logistics in place. It's half of the success. Knowing where to deploy, knowing how to deploy, having a trained team is significant to the results you will have. As I mentioned in the first beginning, I mean, we started with flooding and flood protection, since a lot of companies saw that we could hold back water. They asked if we could help us to assist them in their construction projects. And what you see below is it's a pipeline repair in the shoreline, where we are deploying barriers and then pumping out the water and making a dry work area. The same for these cases. Here we combine our solutions, the flex wall, the self-rising barrier with the tubes. The company had to do a repair of this building. So they were damming up the water upstreams and transporting in our tubes downstream. The alternative to this would be to dam up upstreams and then pump it downstream using huge pumps for 5 weeks. Our approach is very environmental friendly. We let the water flow freely in the tubes and with no impact on the nature. No noise, no energy consumption. So here to the right, we're just emptying the area, but it remained like this for 5 weeks actually. This is another case. I mean, usually we have them in the twin tube configuration, but you can add a third tube on top if you like to increase the protection height. This is a museum we protected. This is another repair project. Basically, they had to make a repair to these culverts. So we deployed the tubes. These tubes are 2.50 meters in diameter, so pretty significant. And we combine it with the flex wall here on the other side, because what we realize is, once you dam up a stream, the water increases, so you always need a significant more amount of tubes and barriers than you really expect. This is a project in Spain. It was a dam repair project, and it was for, I think it was ArcelorMittal. They had to make a repair on a dam, and then they had to lower the level in the lake. And since it's connected to this this natural area, they were not allowed. I mean, they needed to maintain a certain water level in this area to the right. So basically, it was a little bit opposite. We had to ensure we had the correct water level to the right of the barrier, as they are decreasing the water level to the left here. Yeah, now I've flipped the video, but you see how it is. And what we've done here, we have the twin tube, and then we are adding a third tube on top. And then we have the membrane that reduces the seepage level, but also protects against the UV. Talking about construction, different deployment methods. This is a project from Australia. We are deploying the water the barrier in water, filling with water. So basically, it takes like 5 minutes to put the tube over. It takes a few hours to fill it with these small pumps, and then you are emptying the area. I think it took them like half a day, and then they were able to basically to bury the high voltage cables here, as you see with the machines. We enabled the dry work area, and now they could start working with the machines and bury this high voltage cable. This is another project. This is from Belgium, a bridge repair project, where we have deployed the tube on each side of the bridge, and then drained the area between the barriers to establish a dry work area. Yeah, so we have a lot of cases, and when everything is over, what you see here on this image, we have a hydraulic reel where you can use to wind up the barrier after use. It means that it's easy for the labor involved. Since we basically just use machines, we use pumps when we are filling, we are using machines when we're emptying it. So basically, no hard labor work is needed. So it's basically more like a matter of using the technique and a right approach. I'll just give you one more case. It's an old case, but it's still a good one. From Hungary, we had this gas facility. Instead of being flooded, we had an emergency call out, and they asked if we could come and help. And so we did. We drove about 1,500 kilometers in a small rain to the left and with a trailer. And when we deployed it, the water level was like still a meter to the barrier. But shortly after, after 12 hours, we already had contact with the barrier, and then it was a live case. Then the water continued to increase, and actually at day 2, we reached the recommended safety level at 80 centimeters. And at this point of time, we needed more equipment. What we normally do, that would be to deploy a barrier on top of these tubes, forming a triple tube, but we didn't have access to that. So we had to use sandbags. So we made some sandbags piles behind and even on top. And when everything was safe and secured, the Prime Minister was flying in and shaking hands and celebrating the success. This is related to one of the cases I showed you before, but just a stepwise approach. I mean, this area had huge floods. I mean, huge devastation, and then suddenly the year after, they're facing the same trouble again. In the meantime, they've done the flood risk analysis. They done the mapping, which is good because they knew where to deploy the barrier. It was in an open area, and you can see on the photo to the bottom right, the red line is basically where we're supposed to deploy the barrier. And so we did. We were able to deploy it there. And one of the reasons is that if we have very lightweight material, it's 3.5 kilo per running meter. But once it's filled, it's almost 2.4 tons, meaning that 1,000 meters barrier would be, more than 2 million liters. Yeah, 2 million liters for 850 meters of flood barrier. And imagine if you should do the same with sandbags, that would be absolutely impossible because the soil is so wet and slippery at this point of time. Okay, I think I will stop my presentation here, and then I'll be happy if there's any questions.
We should have any questions on the chat of the reunion, but if you haven't had the time to write your questions because you wanted to follow the discussions and the very interesting videos and pictures, you can also make the questions orally, right?
Absolutely.
Okay, in this case, I will kick the ball first. How long will it take you to deploy the barriers, the tube, say for 100 or for 1,000 meters?
Yeah.
You mentioned that anywhere where a vehicle can run, you can deploy but could you?
Yes, I can. Yeah, I can easily say that. With it, all depends on the weather conditions and where you deploy it. If you deploy it on asphalt, it's significantly faster. And usually you do have a road in regards to flooding. You have a road in front of the houses, and so you can benefit from deploying it there. We had last year a new client. They deployed 850 meters I think it was about 900 meters. They did that in about 10 hours with an untrained team of workers. So it was actually pretty good. The first 600 meters probably took 6 hours. The last 400 meters was about 4 hours until it was basically filled. And it was what did slow down the process was the wind. I mean, it has strong wind at this point in time. We had to put sandbags and tie the tubes to different objects, trees and so on along the road to keep it in place. And the approach there, it's like first we fill with, we combine a little bit air and water filling. But primary, actually just water directly into the tube. So, and it's the big barrier. If it's a smaller barrier, the 60 that protects up to 40 centimeters, it's very, very, very fast. I mean, I had a case where I mean, it was actually one of the museum buildings. They should deploy about 200 meters, and they expected a flood on a Sunday. And he asked if I could come and help, and I said, that's fine. If you could prepare the pumps, I'll drop by, and basically in an hour from start till stop, 1.5 hours, including water filling, we've been filling 150 meters. And then due to the weight, you know, you can basically just leave it there and then go back, have your focus somewhere else.
That's very fast, real fast.
Yeah, it's very, very fast. I would say but of course, the more challenging it is, like the first case I showed you. If I'll share my screen again here, and then I'll see if I can come to the top of it. This one, it was very, very, very challenging because first of all, they were not prepared. I mean, they only needed 160 meters, but they were not prepared. And we had to pull it out in a flooded area with 30-40 centimeters of water. And when we are, you know, during the deployment, it increased up to like 70 centimeters of flood water. So this one took significant longer. I mean, we were first ready to deploy around 1 o'clock. And we were completed around 8 o'clock at night, so 7 hours for a triple tube formation. But I would say I don't know about the alternatives because I couldn't see you could use any other solution in this. I mean, you could not see, you could not walk, it was slippery, it was on soil. You had winds, very, very strong wind from one direction. And as we're deploying, you had water going in the other direction. So we had to tie it up with rope, even though there was no objects along this deployment line. We found a few trees, a few bushes we had to use, but it was you know, extremely challenging.
Yes, it is very flexible because I have seen in one of the samples that you were able to get the tube around and in the middle of some trees as well.
Yes, yeah, exactly. So it's very flexible, and we have some loops. I mean, it's a patented solution, but on both sides of the tubes we have a loop, so we can actually use them to tie it to different objects, but we can also use it to navigate. So we just tie these loops together, and then we can have the tube to curve. Yeah.
I don't want to monopolize the question. Are there any other questions from the audience, please? Any other question, please? Well, in that case, just one more question, Anders, please. What do you do with all the water in the tube after the emergency has passed? I suppose that could be reused for the benefit of everyone.
Yeah. I mean, basically, we just borrow the water. So we just take it from the sea, the lake, the river, pump it into the tube, and then when the event is over, we just release it back to the same place where we took it from. So pretty simple and smart approach. So.
Okay. Are there any more questions, please? Okay. In this case, thank you very much. Thank you everyone for your attendance. And as mentioned already, you will have this presentation recorded. The presentation that has been recorded will be available in YouTube, and everyone will be able to review it for details that you may be interested. So the only remaining thing is to thank you very much, Ander, for your excellent presentation. And I hope that it's going to be an eye-opener for flooding reduction in Spain. We will follow that up with you.
Thank you so much. Okay, a pleasure to meet all of you.
Thank you.
Have a good day.
Thank you, you too.
Thank you. Bye-bye.
Bye-bye.